Welcome to section 3.7, graphing linear functions. Now, the first thing I need to talk to you about in this section is function notation. And function notation says, first of all, that if we have an equation and we know it's a function, we can write it as f of x instead of y. But in other words, when you see this f, like in the fancy italicized thing with the x in parentheses, that is exactly the same as a y. So if this is something where it's confusing you right away, you can always replace it with a y, just to help you recognize sort of what it is and how it works. So one thing that we'll have to do this is we have to evaluate it. So what is f of x, what does this equation equal when f of x equals 3x minus 15? Well, the first thing is that x equals -3. So if this is a y equals, instead of that f of x, what we would know to do is just go and plug that -3 in for x. That has not changed here. We're still going to plug the -3 in. So 3 times -3 is -9, minus 15 gives us an answer of -24. So our answer is going to be that -24. However, you can still do this, leaving it in function notation. So let me go and add that cross back to the f. So instead of y equals, you could do this as an f. And then since we're replacing our x here with that -3, you can also actually put the -3 in the parentheses here. And that also tells us that, oh, we're evaluating this function when x equals -3. And you could do it that way as well. Let's look at another function. So f of x equals 2x minus 10. Find the value of x. So now we're actually trying to solve for x, so that f of x equals 6. Well, f of x equals 6, so that means we can replace this whole thing with that 6. So we then can have 6 equals 2x minus 10. We can add 10 to both sides, and we get a 16 equals 2x. Divide both sides by 2, and we find out that x equals 8. So the value of x that works happens when x equals 8. Let's go look at another function. F of x equals 37x plus 7. Graph and identify the range. Well, this is still equal to mx plus b. This is still in slope-intercept form. And is hopefully more helpful if you remember that that's the same as a y equals, is that f of x. So you can think of this still as y equals mx plus b. So our y-intercept starts at 7 and then goes up by 37. So let's just say each of these goes up by, let's just go by 10. So 10, 20, 30, 40, 50, 60, 70. So at 0, our y-intercept is going to be at 7. And then at 1, it's going to go up by 37. So it's going to be about there. And at 2, it's going to go up by another 37. So it's going to be about there. And now you can just go and connect the dots. And you've got your y, or your equation. You've got your line that graphs this function notation, this function that we've got here. Now, let's go and make sure we actually answered the question. Identify the range. Well, the range is asking what y values work. Looking at our function here, we've got arrows pointed in both directions. That means all values of y end up working, which means our range is all real numbers, which can be abbreviated as this R with sort of a double bar on the left side. That's just mathematical shorthand for all real numbers. And it gets kind of fast to write that out instead of just saying all real numbers. Because we can write that, but it takes about 6-7 seconds. Some math teachers also like putting all reals, which also works, but really just doing that symbol way faster than doing either of those. Now, the other thing that will show up in this section is we talk about family functions. And what a family of functions is it's an easier first like most basic function of a certain type and style that you can compare things to so you can understand what's going on better. So for a linear function or a function that's a line, what we're looking at for our function family is just the linear function. And the parent linear function is just y equals x. So when I was going to start teaching math, my sister bought me this mug. And what it has on it is math dance moves. And it's got this little stick figure guy using his arms to create different looking functions. And on this is this little guy right here is just doing x. So it's just going from the lower left up to the upper right. And that's what our parent linear function looks like, is it starts in the lower left, comes through the origin, because it is direct variation, and comes out the upper right. So let's go and, so what we'll end up doing with this is we'll graph lines and then compare them to our original function. So g of x is equal to x plus 3. So first thing we're going to do is we're going to make our y-intercept right here. And then when x goes up 1, our y goes up 1, because this is 1 over 1x. So you go up 1 over 1, and then we can go up 1 over 1, and then we can go up 1 over 1. And we've got this equation, or this function. Now, our original equation, y equals x, that's going to go through your origin at 0, 0. And you're going to go up 1 over 1, up 1 over 1, up 1 over 1. And if you go and draw that, that's your parent linear function. So if you're going to compare these, you also just need to be able to talk about what's the same, what's different. So things you know about and can talk about. The y-intercept. The y, let's see. So from the parent linear function, the new one, you can say the y-intercept was is up 3 from your basic function. You can talk about slopes. Well, this one has a slope of 1. This one also has a slope of 1. So you can say they have the same slope. If they're pointed, like one's going up and one's going down, you could say one's increasing while the other decreases. But this isn't doing that. So intercepts and slopes, that's pretty much all the more you can compare at the moment. Let's try this one. So in this case, our b is 0. So we're still going to go through the origin, and we're going to go up 2 and over 1. And then we go up 2 over 1, and up 2 over 1. And so we can go and draw and connect the dots. So this is that h of x function. Now we can still go back to our parent function and go through the origin, up 1 over 1, up 1 over 1, up 1 over 1. So you can see, just looking at them, one's getting steeper faster. Well, and it also makes sense, because if one is y equals x and the other is 2x, the other one's getting bigger twice as fast. So you could say that the slope is doubled. And that would be a valid way to say it. When we're talking about our y-intercepts, y-intercepts are the same. And we know that that's also true. So let's go and compare one last set of equations, and then we'll be done for the day. So we need to compare this function with this function. Well, this one has a y-intercept of 40, and it's going up by 60. So let's go up by 20s. So 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. And 1, 2, 3, 4, 5, 6, 7. So we're going up by 1s across our x-axis, up by 20s on our y-axis. So for this first one, let's do this in red. So we cross at 40, and then we go up by 60 each one. So at 2, we go up to 60, and then 3, we're up to 220. So here's that first line. And for g of x, that one starts at 5. Let's go and graph this one in, let's go purple. So if that's 25 is going to be about here, then we go up 60 and over 1. And then we go up 60 and over 1. And then we go up 60 and over 1. Well, for comparing these, their y-intercepts are 15 different. So y-intercept is up 15 for f of x. For their slopes, both of their slopes are 60. So they're actually going up by the same amount. So you could say that slope is the same. And the reason that this came in is it was actually a word problem from the book. It's on page 203, but it's comparing costs for cable from cable companies. One is doing they're both $60 a month, but one charges $40 for installation and the other had a sale, so it's only $5 for installation. So if we're comparing these, the slopes are parallel, like the lines themselves are parallel. So they're never going to intercept, which means this purple line, that bottom one, the g of x, is always going to be the cheaper option. So if you had the choice, you should have gone with g, especially if it was with the same company. So that's just one way that we could also compare these in real life. So that's it for this lesson. If you have any questions, let me know. And as always, good luck.